And now let's talk about inflation. So we know that with the time value of money, the main issue which causes the time value of money is inflation. Okay, so inflation is expected to go up by 2, 3, or 4% each year. That's kind of normal. That's what the reserve banks tend to target. But we know that for the last couple of years, inflation has been really, really high because the Ukraine war, supply chain issues, COVID. So inflation, as most of us probably understand, has gone through the roof, right? So basically, traditionally we look at CPI, the Consumer Price Index, as the means of how we actually look at how the cost of living has actually increased over time, right? So what happens to Consumer Price Index is the cost of a basket of predefined goods. So as this box or basket of goods goes up over time, then basically we kind of say that CPI has gone up. So traditionally, what does CPI? So traditionally, prices tend to rise over time, and we know this impacts the time value of money. So inflation also affects our investments. So we need to account for inflation in our cash flows. So if we don't account for inflation, we're overestimating the benefits of a project. So we should never assume that money in the future will have the same purchasing power as today. So usually when we talk about discount rates, it's to account for all the risk of the project. So you imagine that your discount rate should account for, inflation, the risk of the project, so on and so forth. Okay, so let's think of it this way. Imagine you lend someone $100 and they agreed to pay you back at the end of the year with interest. But you decided on a 4% interest rate, but it turned out inflation already was 5%. So that means you actually lost money. Okay, because what happens is that if we look at the amount that was repaid, which was 100 times 1.04 divided by 1 plus total inflation, you actually got back $99, which means you lost out on a dollar. So that's inflation, and I think we know inflation quite well. Okay, so the point is we need to include inflation in our estimates. Okay, so basically what happens is that what we need to understand is the difference between the real interest, nominal interest, and inflation. Okay, so what we actually need to work out is that when we evaluate projects, we should be looking at real interest. Okay, that's given by 1 plus nominal interest and 1 plus inflation. So we worked out that the real interest from what we lent in the slide before is actually 0.952% because we lost money. So you put it out over here, we lost money over here. So the real interest received was negative 0.952. So therefore, when evaluating projects, use inflation-adjusted cash flows so we don't overestimate returns. To look at inflation, we take total inflation, closing value divided by opening value minus 1. Or we look at the average annual inflation, we look at closing value divided by opening value to the power of 1 over number of years minus 1. We use the periodic holding period return because we are not aggregating. Okay, so if we think about the average annual inflation formula, right, it's the reverse of our effective interest rate formula. So it can be used for a lot more than just inflation, right? You can find annual returns when you have a 10-year return or monthly returns when you have an annual effective return. Just change the number of years to the number of annual compounding periods. So this is not a new formula, okay? I know that for most of you, you guys might be getting confused. There's lots and lots of different formulas, but it's basically a rehash of the same formula. So I just want you guys to know that it's just a reverse of the effective interest rate formula. Okay, so that's how we incorporate inflation in our projects. Okay, now let's look at an exercise on inflation. Okay, so if you know CPI values through the life of your project, you can adjust individual cash flows for longer term projects. Okay, so what we're going to do over here is we're going to calculate the total inflation for each year, adjust each cash flow for inflation, getting the future payment in today's dollars, and use IR to evaluate the project again. Okay, so let's do it step by step. Okay, let's look at the inflation part of it. So what we have over here is that we have, to calculate total inflation, it's going to be 1981 divided by 1980 minus 1. Okay, so we get, that's our inflation. So what we actually need to do is actually, because normally if we actually have this is actually, so let's look at what we have over here, okay? This is actually year-on-year inflation, right? But what we actually want, okay, is actually inflation compared to the time at which we actually the time at which we actually started our project, which is 1980. Okay, but this is actually year-on-year inflation, right? Okay, but what we're actually looking for is total inflation. So what happens? How did prices grow up each and every year? Okay, so just bear in mind that that's actually the difference between what we have over here. Okay, so what we actually want to do is that, let's say, take that away. That is what we will call year-on-year inflation. Okay, and we can see that the average would be 3.7%. And let's look at that. Let's also increase that a little bit. So we see that year-on-year inflation increases about 1 to 4%, which about makes sense, okay? But what we're actually looking about is total inflation. So what's that, right? So what we need to do is actually we need to take this divided by that, and we have -1, okay? And we bring it all the way down, and we look at the percentages, and we see, wow, look at that, okay? In about 20 years almost, prices have gone up by 71%. So that's huge, isn't it? Okay? So that explains why, all your, parents would always come and go, or grandparents, or look at how expensive things are. It's because inflation will do that to you. Okay? So what happens if you want to find the average inflation? Then we actually take, we get B20 minus B2, okay? The power of 1 over 18 minus 1, okay? That gives us the average inflation was 3.04, which is exactly the same as what we have here. So what we did over here, we took actually the final price, divided by 1, and actually said that we actually took the square root of 18 because there are 18 years here. Okay, we can tell from that because let's see over here, there are 18 times of compounding. All right, so I hope all of that makes sense about total inflation and year-on-year inflation. They're different. Okay, so what we call was total inflation. So that's done, part 1. Great. So now let's look at the adjusted cash flows. Okay, so adjusted cash flow is actually going to be total inflation. Okay, so basically, just drag all that down. Okay, so what happens is that what we're saying over here is that the $100 we receive is actually $96, and then it gets smaller and smaller and smaller. So these are all the present value amounts, right? So we can see that it's actually really, 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 really tiny at the end of the day. Okay, so what we're going to do, we have the IRR. Let's say we look at the rate. It's going to be equals to IRR of all of that without incorporating inflation. But let's look what it looks like when inflation is incorporated. Okay, so I'm just going to put that here. I'm going to say that it's negative 1,000. And we can see when we actually incorporate inflation, the rate of return it's much smaller. It's actually half, which is tiny. Okay, so basically what happens over here, that actually just shows you right? That you got to incorporate cash flows for inflation. Okay, so in short, okay, if you actually even had something, let's look at so basically that actually shows you that IRR is so different when inflation is incorporated. Okay, so that's pretty much it for the subject. And over here, okay, if you look at exercise, we have this area where we explored, okay, these are the cash flows. If you actually incorporate the average inflation over time, and you'll find that it's slightly higher, okay, than knowing it for every period, because this is an average, okay? So ideally, if you only hit the first and last CPI figures, right, your IRR might be slightly higher than it should be, right? But usually you have access to all CPI data, so this shouldn't be an issue, right? So that's the one thing which you just want to be aware of. So with that, thank you for listening to the lecture. I hope you've actually learned a lot more today about different issues to account for when you're doing capital budgeting. So there's things like inflation, mid-year discounting, using tools like MIRR, okay, which allows you to adjust for different rates of return. Things like XIRR, XNPV, which actually just allow you to actually do more accurate NPV and R calculations when you have dates included. Okay, so MIRs when you have different reinvestment rates and different financing rates. And we also talked about how you choose between different projects with unequal lives, that you have the equivalent annuity method or replacement chain method. So that's what we covered for today. So I hope you've enjoyed today's class, and I hope that you will join me for the tutorial next. Thank you.